Hello, students. Your teacher here, Mr. Sirosinski, with another episode of Algebra 1, Lesson 8.7, Solving Quadratics by Square Roots. And we're getting close to the end here. So let's go ahead and get started. This is another way to solve quadratics when they are in the form ax squared plus c equals 0. So when there's no b term. So far you have factoring as your main tool to solving quadratics to find the x-intercepts. Remember, that's what this is all about. But not every quadratic can be factored. Or some are just easier to solve this way. So how do you do it? Well, the first thing you do is isolate the x squared term. So we're going to add 49 to both sides in this example. So you get x squared equals 49. And then to undo something that is squared, we take the square root. Okay? And the square root of x squared is x, and the square root of 49 is 7. But for every square root, okay, there are two answers, and that's what this is referring to here. Every square root has two answers. So yes, 7 times 7 does equal 49. So 7 is the square root of 49. But also, negative 7 times negative 7 equals 49, because a negative times a negative is a positive. So when we solve square roots like this, we always say plus or minus the root. Okay? This is saying that 7 times 7 is 49, and negative 7 times negative 7 is also 49. All right, moving on. Number 1, add 16 to both sides. X squared equals 16. Take the square roots, and x equals plus or minus 4. Add 100 to both sides. X squared equals 100. Take the square root. X equals plus or minus 10. Subtract 25 from both sides. X squared equals negative 25. Take the square roots. And x equals nothing. What? What are you talking about? Well, let's think about it. What can we multiply? Sorry, my hand keeps shifting the screen a little bit. What can we multiply by itself to get negative 25? 5 and 5, you say, oh, well, 5 times 5 is positive 25. And negative 5 times negative 5 is still positive 25. There are no numbers that you can multiply by themselves to equal a negative, okay? So if you're solving these and you get x squared by itself, but on the other side you have a negative, no solutions. That means and it's not like a terrible thing. It just means that the graph of this quadratic does not cross the x-axis. That's simple. Okay, number 4. Subtract 7 from both sides. X squared equals 81. Take the square roots, and x equals plus or minus 9. Number 5, add 5 to both sides. X squared equals 1. Take the square root, and x equals plus or minus 1. Yeah, the square root of 1 is 1, because 1 times 1 equals 1, and negative 1 times negative 1 also equals 1. Number 6, oh, this one we have to divide to isolate the x squared term. And we get x squared equals 9, and then take the square root, x equals plus or minus 3. Number 7, divide by -2 to isolate the x squared term. X squared equals positive 49. Take the square root. X equals plus or minus 7. Number 8, in order to get rid of a fraction, we multiply by the reciprocal on both sides. Cancels out, and we get x squared equals, let's see, 48 times 4. That's 160 plus 32. That's 192. Divided by 3, that is 64. And the square root of each, x equals plus or minus 8. All right, divide, oh, here we have a two-step. Add 108. Divide by 3. And x squared equals 36. Take the square root. X equals plus or minus 6. Number 10, two steps. Add 45 to both sides. So we're trying to isolate the x squared term. Divide by 5. And x squared equals 9. Square root each side. X equals plus or minus 3. Moving on, number 11. Two steps, subtract 66. 7x squared equals negative 63. Divide by 7, and x squared equals negative 9. And since this is negative, remember, going back to number 2 or 3 here, if you have a negative on the right side, you cannot take the square root of it. There's nothing you can multiply together that's the same to equal a negative. It has to be opposite signs. So this is no solutions. Number 12, subtract 3. Multiply by the reciprocal of 1/2. And the square root of 144 is plus or minus 12. 13. Oops, shrink that up a little. Add 16 to both sides. Divide by 9. And if we take the square root of these, we get x equals plus or minus 4/3. So anytime you take the square root of a fraction, okay, so we had the fraction, we had the square root of 16 over 9. You can also write this as the square root of 16 over the square root of 9. And we know what the square root of 16 is. That's 4. We know what the square root of 9 is. That's 3. And we can just leave it in fraction form. Plus or minus 4/3. Number 14, subtract 10. 25x squared equals 36. Divide by 25. And we don't have to worry about reducing this, okay? We're going to just take the square root. And x equals plus or minus the square root of 36 is 6, and the square root of 25 is 5. So this is plus or minus 6/5. Number 15, ooh, got to get the x squareds on one side. We're going to subtract x squared from both sides. And we get 4x squared minus 1 equals 0. And we're going to add 1 to both sides. 4x squared equals 1. Divide by 4. X squared equals 1/4. And we take the square root. The square root of 1/4 is like the square root of 1 divided by the square root of 4. And the square root of 1 is 1. And the square root of 4 is 2. So it's plus or minus 1/2. Number 16. Get the x squared by itself. Add 34 to both sides. divide by 16, and the square root of 49/16 is 7/4, plus or minus. All right, so sometimes our answers, when you're taking a square root, not every number can be square rooted, okay? And so when a number can't be square rooted, like for example, the numbers that can be square rooted are 1, 4, 9, 16, 25, ... But in between these numbers, like 2 and 3, 5, 6, and 7, if we were to square root these numbers, there would not be a perfect square. It would not be a whole number. It would be an irrational number. And if you don't remember what irrationals are from like the first lesson of this class, it is a number whose decimal never repeats or terminates. It is just a never-ending number, okay? Similar to pi, okay? So let's see what that looks like. Add 3 to both sides. X squared equals 3, square root x equals plus or minus the square root of 3. And we don't have to simplify it any more than that, okay? Because if we were to do this in our calculator, the square root of 3 is a really long number. So why don't we just leave it as the square root of 3? Because it's nice and short and compact. Number 18, add 8 to both sides. Take the square root of 8. And here we have an interesting situation. So 8 can be broken up into its factors, right? So we want to try, if we can, to simplify a radical as much as possible, okay? And so if we have the square root of 8, we can simplify this into, we're looking for a perfect square factor, okay? We're looking for, look for perfect square factors. Let me erase a little bit of this so I can get all my words in there. Perfect square factors. Perfect square factors are like these numbers here that I listed. And so when we're simplifying an irrational or a potential irrational answer, we want to try to simplify it as much as possible by identifying any perfect square factors and factoring them out of the radical. So we can break the square root of 8 up into two parts. The square root of 4 times 2, or the square root of 4 times the square root of 2. And the square root of 4 is 2 times the square root of 2. And so the square root of 8 and 2 times the square root of 2 are identical answers. So this would be x equals plus or minus 2 times the square root of 2. Number 19, subtract 8. X squared equals 48. And let's think, are there any perfect square factors of 48? Well, we want to try to get the biggest one, and the biggest one is 16, because 16 times 3 equals 48. So I'm going to rewrite this when I take the square root as x equals plus or minus the square root of 16 times 3. And I can take the square root of 16, right? Just like if I had them separate. Square root of 16 times square root of 3. And the square root of 16 is 4 times the square root of 3. So x equals plus or minus 4 times the square root of 3. And this and the square root of 48 are identical. All right, number 20, add 16. And we're looking for a perfect square that will go into 75. How about 25 times 3? So before we take the square root, let's break this up into 25 times 3. Or the square root of 25 times the square root of 3, whichever is easier for you. And then x equals plus or minus 5 times the square root of 3. Number 21, add 126. Divide by 2. And we need a perfect square factor that goes into 63. How about square root of 9 times 7? And the square root of 9, and again, or the square root of 9 times the square root of 7. Square root of 9 is, so this would be plus or minus 3 times the square root of 7. Subtract 8. Divide by negative 3. And are there any perfect squares that go into 10? I don't think so. So x equals plus or minus the square root of 10. Let me just double check real quick. I want to tell you guys wrong. Yeah, no, x equals plus or minus the square root of 10. Okay, and I should have been circling my answers along the way here. Number 23, add 10. Divide by negative 1. And anytime you have x squared with a negative on the other side, remember, no solutions. Number 24, add 11. Multiply by the reciprocal of 1/2, which is 2 over 1. Factors of 72, there is a perfect square factor, 9. 36. There's got to be, 36 times 2. This is the one we want. So this would be x equals plus or minus. Right, we're going to take 72 and we're going to break it up into the factors of 36 and 2. And we can take the square root of 36. The square root of 36 is 6 times the square root of 2. So it's x equals plus or minus 6 times the square root of 2. That was lesson 8.7, solving quadratics by square roots. If you had some trouble with these irrationals, I invite you to maybe go to Khan Academy or just Google simplifying irrational radicals, and maybe look over some notes, watch a video. It's I think once you get it, you get it. It's not, but if you're seeing this for the first time, it might be a little confusing. I am your teacher. This is the way.